Demultiplexer is a device that forwards single input to one of the multiple output lines, and we can select output line using selection input lines. So in demultiplexer we can have only one input line, n number of selection input lines, and 2 to the power n number of output lines. Demux is the short form of demultiplexer. So this is the block diagram of a demultiplexer. Here is the one input line, here are the 2 to the power n number of output lines, and these are the n selection input lines. So 1:4 demux. Here 1 indicates number of input lines and 4 indicates number of output lines. So we have 2 to the power 2 number of output lines. That means we have n equals to 2. So we need 2 selection input lines. This is the truth table for 1:4 demux. This is the block diagram, and these are the Boolean expressions. Now we have 4 output lines, so we need 4 Boolean expressions. So when our selection inputs are 0 0, we want the input y at I0. When our selection inputs are 0 1, we want the input at I1. For 1 0, we want the input at I2, and for 1 1, we want the input at I3. When S0 is 0, S1 is 0, we will get the expressions like these: 1 into y equals to y, 0 into y equals to 0, 0 into y equals to 0, and 0 into y equals to 0, because in that case only this product will be 1 and the other products will be zeros. So we will get y only at the output I0, and the other outputs will become zeros. When S0 is 1, S1 is 1, then we will get the expressions like this: 1 into y equals to y, because in that case only this product will be 1 and the other products will become zeros. So we will find y only at I3, and in the other outputs we will get zeros. This is the logic diagram of 1:4 demux. So when our pattern is 0 1, then our S0 is 0, S1 is 1, so we will get S0 prime as 1, S1 prime as 0. So for our first AND gate, we will get the inputs as 1 0, so our output will be 0. For the second AND gate, we will get the inputs as 1 1, so our output will depend on y, because here another input is y. For the third AND gate, our inputs are 0 0, so our output will be 0. For the fourth AND gate, our inputs are 0 1, so our output will be 0. So for this pattern, we will get y only at I1, and in the other outputs we will get zeros. For this pattern, our S0 is 1, our S1 is 0, so S0 prime will be 0 and S1 prime will be 1. So for the first AND gate, our inputs are 0 1, so our output will be 0. For the second AND gate, our inputs are 0 0, so I1 will be 0. For the third AND gate, our inputs are 1 1, so I2 will depend on y, because the other input is y here. For the fourth AND gate, our inputs are 1 0, so we will get 0 here. So for this pattern, we will get y only at I2, and in the other positions we will get zeros.